Section 5.1, Probability Distributions. Key concept. This section introduces the concept of a random variable and the concept of a probability distribution. We illustrate how a probability histogram is a graph that visually depicts a probability distribution. We show how to find the important parameters of mean, standard deviation, and variance for a probability distribution. Most importantly, we describe how to determine whether outcomes are significantly low or significantly high, or neither. Now, the basic concepts of a probability distribution. A random variable is a variable, typically represented by x, that has a single numerical value, determined by chance, for each outcome of a procedure. A probability distribution is a description that gives the probability for each value of the random variable. It is often expressed in the format of a table, formula, or graph. A discrete random variable has a collection of values that is finite or countable. If there are infinitely many values, the number of values is countable if it is possible to count them individually, such as the number of tosses of a coin before getting heads. Now, a continuous random variable has infinitely many values, and the collection of values is not countable. That is, it is impossible to count the individual items because at least some of them are on a continuous scale, such as body temperatures. Now let's take a look at the probability distribution requirements. Every probability distribution must satisfy each of the following three requirements. Number one, there is a numerical, not categorical, random variable x, and its number values are associated with corresponding probabilities. Number two, the sum of all the probabilities is equal to 1, where x assumes all possible values. Again, this is translated as the sum of all probabilities must be 1, but sums such as 0.999 or 1.001 are acceptable because they result from rounding errors, because those are pretty close to the value of 1. And number 3, all probabilities of x must be in between 0 and 1 inclusive for every individual value of the random variable x. That is, each probability value must be between 0 and 1 inclusive. Now, the second requirement comes from the fact that the random variable x represents all possible events in the entire sample space. So we are certain with probability 1 that one of the events will occur. The third requirement comes from the principle that any probability value must be 0 or 1, or a value in between 0 and 1.